Hi guys, I'm Anamika and I'm going to talk on chapter 6 of our textbook, that is IT infrastructure and architecture. Today we are going to start with seeing the relationship between IT strategy, IT architecture and IT infrastructure. We are going to proceed with the seeing what role does the manager play in deciding on an IT architecture. Then we are going to see some common types of IT architectures. Then we are going to see a framework which for the analysis of IT architecture and the IT infrastructure. Later on, we are going to see how is cloud computing and virtualization playing an important role and how it is how it is contributing to the evolution of the business world. Then we are going to see what is enterprise architecture, then some architectural principles, and then we are next I am going to conclude the video with some discussion points which we can discuss later on in the class. So yeah, let's get started with the video.
In this chapter, we are going to understand how is architecture driven by strategy, which further drives infrastructure, how are business goals translated to architecture and then into infrastructure. We are going to see some frameworks to do this. We are also going to see the importance of virtualization and cloud computing. What role does it play if an infrastructure is shifted to cloud? And we are also going to know the importance of understanding the details of existing architecture and infrastructure by a manager. Terms architecture and infrastructure are often used interchangeably in the context of IS. So are they the same thing? The answer is no. So what is the relationship between them? Architecture actually drives strategy into infrastructure. We can understand this with the help of an example. Uh, Consider building a house. So the owner has a vision of how his house should live, of how his house should look like. Uh, he should have a strategy where to live in, like in an apartment or in a house. His strategy must also include how he wants his house to be. Like, should there be a gaming room? Should there be a music room? Uh, Etc. etc. So he goes to an architect who actually plots this as a plan on a piece of paper. This paper then acts as a guide for the builders, like for the plumbers, electricians, and the carpenters who actually build the house. Uh, the the carpenters, I mean the builders, based on their past experiences, they select the material of the house, what is best suited for the house, and then they start building the house according to the plan which our architect has given them. So after the completion of the building, owner's vision has come into existence. The totally abstract idea from the owner's mind has come into a concrete reality. So here we can consider the owner's vision as strategy if we apply this thing into information technology, the architect's plan as architecture, and the builder's implementation as infrastructure. So this is how architecture drives strategy into infrastructure. So the IT architecture can be defined as blueprint for translating business strategy into a plan for information systems, and the IT infrastructure can be defined as everything that supports the flow and processing of information in an organization, including the hardware, software, data, and network components. Though the homeowner in the previous example doesn't plot up a plan, nor he pounds the nails, but he knows what to expect from the architect and the builders. Similarly, a manager should know what to expect from IT architecture and infrastructure so that he can make full and realistic use of them. He should communicate his business visions to the IT architecture very clearly, and he should modify the plans if IT cannot support those. The manager must be involved in the decision making process, otherwise everything will go wrong. So to make the manager's work easy, translation of strategy to infrastructure is broken down into two steps. That is translating strategy into architecture and then translating architecture into infrastructure.
So now we are going to see the leap from strategy to infrastructure by breaking it down into two steps. First is from strategy to architecture, and then from architecture to infrastructure. So a manager in general should always start with a strategy in mind of what is expected out of the business. This strategy can further be used to find out specific goals uh, which together can contribute to the fulfillment of strategy. Each goal can be used to find out several business requirements. Business requirements may include requirements such as business objective, the vision of the business, and such things. Now, after finding out the business requirements, the manager should work with the architect in order to find out architectural requirements. These architectural requirements are the requirements. Here, what is decided is what sort of servers to use, what operating system should be used, and also the security objectives are also included in this architectural requirements. Now, from the details of these architectural requirements, like from all the architectural requirements, the architect should jot down a plan, and he should put it on paper and design the architecture for the business. This architecture actually tells us what services and applications are going to be used in the business. Now, this architecture is added with much more details like hardware, software, data and networks, and then are translated into functional specification. This is another important step of translating architecture into functional specifications. The functional specifications can then be broken down into hardware specification, software specification, network specifications, and so when we are talking about infrastructure, we are not talking about a single component. We are talking about combination of all the components. So to build an infrastructure, all these components should be combined and put together according to the architectural plan. And this is how we can translate architecture into infrastructure successfully. Yeah.
4 components to be considered while developing a framework for transformation of business strategy into architecture and then into infrastructure. So these are hardware, software, network and data. Hardware, as you all know, are the physical components that handle computation, storage or transmission of data. Example of hardware are like RAM, hard drives, your personal computers, modems, etc. Software are the programs that run on the hardware to enable work to be performed. Um, Examples are operating systems, word processors, and yeah, your ERP systems. Software is usually divided into two groups. One is system software, and another is applications. So system softwares are softwares like Microsoft Windows, Linux, and applications are like word processors, digital photo editors and all. So yeah, and network. Network is a collection of software and hardware components for networking. Networking can be local networking or long distance networking. So local networking components include switches, routers, hubs, and long distance networking components include cables and fibers. So some of these networks are private, which requires your credentials to connect, and others like internet are public. Data is the electronic representation of numbers and text. Here, the main concern is the quality and format of the data, and how many times the information is transferred from one piece of hardware to another piece of hardware, or how many times the information is translated from one format to another. Framework which guides the analysis of the four components we have discussed in previous slide is discussed in the chapter 1 of our textbook. This framework uh, answers three types of questions for each and every component of our infrastructure. The questions are what, who, and where. What is the most commonly asked question, and it identifies the specific type of technology. The who question seeks to understand what individual groups and departments are involved. In most of the cases, individual user is not the owner of the system, or even the person who maintains it is not the owner of the system. In many of the cases, the system are leased, they are not owned by the company, and making the owner a completely third party outside the organization. Uh, so it's important to get a picture of the people who are involved to understand an infrastructure. The third set of questions addresses where issues. Due to wide expansion of our networks, many IS are designed with and built with components in multiple locations, even across the oceans. So learning about infrastructure means understanding where everything is located. So these are some of the questions out of many which needs to be addressed. Actually, the specific type of question depends on the business strategy an organization is following. Uh, Still, these questions can be helpful to IT staff asking their managers to provide further information as they seek to translate strategy into architecture and ultimately into infrastructure. The answers derived with IT architects should provide a very robust picture of the full IT environment. That is the data and the information, what technology is used, etc. Traditionally, the three common types of architectures used are centralized architecture, decentralized architecture, and SOA, that is service oriented architecture. So in centralized architecture, everything is purchased, supported and managed centrally, usually in the data centers. Centralized architecture is also called as mainframe architecture. Here only the mainframe needs to be protected for the security purpose. Whereas in decentralized architecture, the computing power is spread out among a number of devices in different locations. The hardware, the software, networks, and data uh, are such that the processing and functionality is distributed between small computers and servers and devices which rely on a network to be connected with each other. So here they can communicate with each other as long as they are connected. Uh, Decentralized architecture is also called server based architecture. Here security is difficult as compared to the centralized architecture because servers are dispersed in context to their location. So here we have to secure each and every server instead of one as we used to do in centralized architecture. The service oriented architecture, uh, in this the software is broken down into small services. These services then together form an application for the entire business. SOA is also called as cloud based architecture. uh, This gives rise to a new level of security issues because here the data is not present in some physical machine, rather it is present in the network uh, that lies in cloud and that ties the web together. Uh, so while considering the while making the architectural decisions, a manager should know the trade-offs between these between the architectures. The other commonly used architectures nowadays are peer-to-peer architecture, wireless infrastructure, and web-based architectures, that is the cloud architectures. So in peer-to-peer architectures, what happens is that a group of networked computers can share resources without a need of central server. That is, they can exchange information as long as they are connected to each other. A good example of this is Skype. As we all know that Skype we can use for teleconferencing, texting, video calling, telephoning, uh, etc. So this is the example of a business that uses a peer-to-peer architecture. Uh, the wireless infrastructure allows communication from remote locations using a variety of wireless technologies. For example, the cellular data which we use on our mobile uh, mm, is an example of this, and the wireless WANs, the satellite links can also be considered examples of wireless infrastructures. Uh, Whereas the web-based or the cloud architectures locates all the hardware, all means the specific hardware, softwares, and even the data elements on the internet. Uh, so this type of architecture offers a great flexibility uh, when when the availability of additional processing capability can be given for a fees, like whatever amount they should charge for that particular use of the internet. Principles are the backbone of architecture. Any good architecture is based on a set of principles about how the architecture should function. So the principles are designed by considering the key objectives of the organizations. Those though these there is no set of list what all should be included in an architecture in the architecture principles, but they should be directly related to the operating model of an information system organization. They should also define the role of organization that supports it. Enterprise architecture is a broad design that includes both the information system architecture and the intercorrelationships in the enterprise. It basically organizes a logic for the entire organizations, and it 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 sees the core processes and how they'll work with each other and how the IT system is going to support them. Nowadays, all the business processes involve some component of IT, uh, and that's why the business processes are designed concurrently with IT systems. So, this is a joint exercise to be done with both business and the IT leaders. Uh, I have found a small video which gives a rough idea of enterprise architecture using an enterprise architecture tool which is Abacus. So let's see the video.
Companies rely heavily on their IT department, and as businesses grow, they need new applications and technologies which can eventually number in the thousands. Effective IT teams find ways to stay one step ahead, manage change, and plan for the future. The Abacus toolset is designed to help you do this. With Abacus, you can capture the interconnected structure of your business, the organizational structure, the process structure, right down to your infrastructure. You can import large data sets easily and round-trip data with Visio, Excel, and SharePoint. You can model, analyze, and present this information using rich visuals. You'll find it refreshingly straightforward to integrate your other inventories and repositories. Abacus's open API allows you to stitch together key company data in one place and keep information from complex businesses consistent and up to date. You can perform impact analysis, build detailed roadmaps, and evaluate future state scenarios. Abacus also provides simulators for KPIs such as cost and risk. Its flexible repository allows you to set the metrics which matter the most to your business and use these in trade-off analysis and presentations to key stakeholders. Ultimately, Abacus allows you to understand your IT landscape, react quickly to change, and navigate the future with confidence.
Replacement of physical data centers by virtual infrastructure is called as virtualization. In this, the computing capabilities, storage and networking are provided by a third party over the internet. For example, consider I am having a laptop with Windows operating system. I can create a virtual machine on my laptop, and I can assign some storage place to it, and I can run a Linux server on it. This means that my device, that is my laptop, is locally accessing a desktop software on a remote server, which is actually separating the OS from application. Uh, so cloud computing is based on the concept of virtual infrastructure itself. In this, entire computing infrastructure is available in the cloud, where cloud refers to large cluster of virtual servers or storage devices. So this we call as infrastructure as a service. The cloud computing customers purchase capacity on demand. Here comes the concept of utility computing, that is pay as you use. Users like this concept of utility computing because they have to pay only for the amount of services they have used, based on the duration or on the amount of data they used. So basically here what happens is, third party infrastructure is used by a company to do all their processing and pay only for what they use. Examples of the applications in cloud are Facebook, Gmail, etc. But if but cloud computing, if used, managers should also understands the risk of depending on the third party supplier, giving the control of full data to the third party. uh, Either he should know either the data is private or he's sharing with some other party for their ads or something like that. There are many benefits of virtualization and cloud computing. They can eliminate the need of many physical servers, reducing the physical costs of data centers. The fees can be based on transaction volume rather than large upfront investments. There is no need to devote physical space for the large servers. There is no need to worry about uh, large data centers, so that cuts costs too. Uh, there is no upgrade, maintenance and electricity charges for cloud computing. Uh, Cloud computing is dynamic by design, so adding capacity is quick and easy as compared to the traditional data centers, where we had to purchase hardware, then install it, then there would be some delivery and compatibility issues for the additional capacity. So all these things can be overcome by cloud, um, and hence it helps reducing cost in many ways. The infrastructure and architecture framework, which we have seen, guides the manager towards the design and implementation uh, of a good, appropriate infrastructure. It is relatively simple to define an IT architecture, but when it comes to the time taken for its installation, the needs may change over time. So there are some other points to be considered by the managers, uh, like understanding existing architecture. The manager should understand the existing architecture so that he can evaluate IT requirements of the developing or the upcoming business strategy against the current IT capacity. Mm, by comparing the future architecture and the current infrastructure, he can also determine the components which can be used, reused, and advanced in the upcoming architecture, uh, so that no need to spend more, or no need to waste time on the same things again. For this, the manager can ask certain questions such as what architecture is currently being used, uh, and is the company developing IT architecture from scratch, and like there is nothing developed already. Is the company replacing an existing architecture? Uh, does the company need to work within some confined existing architectures, or is the company expanding an existing architecture? So what is actually in existence should be considered by the manager, and what is going to be done in the future is, of course, should be considered by the manager. It is also very important for a manager to understand the lifespan of an IT infrastructure and architecture. He must also determine how far that strategy will extend into the future, and uh, like what what will be the consequences that it may go down. Uh, the strategic time frames depend on industry-wide factors like level of commitment to fixed resources, or like maturity of the industries. Uh, the degree of managers' reliance on IT, and the rate at which that technology is advancing also is a major contributing factor, deciding factor in the architectural longevity. That means how far that architecture is going to go, and uh, uh, how soon it is going to sink. In today's world, architecture must have really maximum flexibility and scalability. This is because uh, if there is a need of handling large business changes, the flexible and scalable architectures are totally able to bear such changes. Some other managerial considerations include assessing technical issues such as adaptability, scalability, security, and standardization. Adaptability means an organization must be able to handle expected technological advances both in the storage and computing power. Nowadays, building a static information system to support the business is no longer feasible, as every now and then the requirement and expectations are changing. Every IT architecture should now be adaptable to any changes. Adaptability contributes to the core design to a core design principle, which is why the cloud computing and virtualization are increasingly popular nowadays. Now we come to scalability. The term scalable refers to how well an infrastructural component can adopt increased or decreased in demands. Increased or decreased demands. So a scalable system could start with just few nodes, but could easily be expanded to include thousands of nodes in the system. It is an important feature which makes sure that the firm will not outgrow the investments decided to make in an architecture and infrastructure. Standardization deals with most commonly used standards. Standardization means the hardware and software that adheres to industry standards should be adopted. For example, many companies use MS Office software, making it almost the de facto standard to use. Uh, the security refers to protecting the key data and the process elements of an IT infrastructure. I've already discussed about security while discussing the types of architecture, the centralized, decentralized, and the SOA architecture. Now comes assessing the financial issues. Like any other business investment, IT infrastructural components should also be evaluated based on their expected financial value. It is quite difficult to quantify this as it can come in any form like increased productivity or improved customer services, etc. Still, there are some steps which can be helpful to quantify the return on infrastructure investments. These include quantifying costs. Quantifying cost means costing out the proposed infrastructure components and estimating total investment necessary on them. We can also determine in advance the life cycle of system components. Quantifying benefits and quantifying risks also help towards quantifying the return on infrastructure investments. Considering ongoing dollar costs and benefits, which means examining how the new equipment affects maintenance and upgrade costs associated with the present infrastructure, also contributes to quantify the return on infrastructure investments.
In this chapter, we have learned one, the strategy drives architecture, which in turn drives infrastructure. We have seen three architectural configurations, that are centralized architecture, decentralized, and the service-oriented architecture. We have learned how important it is for the manager to understand how to plan IT to realize his business goals, and then we have seen why it is important to understand the existing architecture and the infrastructure while translating business strategy into architecture and then into infrastructure. So I have some discussion points later on in this slide, which we can discuss in the class on Wednesday. So bye guys, see you all on Wednesday.